Good morning, everyone. I am Roshy John. I am the founder and CEO of RoshAi. We are focusing on a deep tech area called in driverless domain. So I just want to walk you through the reason why I started a driverless car, and that too in India, driverless car company or a startup in India. That too in India, and that too running in a tier 2 kind of a city. So in 2010, I was working as the senior scientist at LG India R&D Center. I was mostly into driverless, robotics and systems development. Then there was one time when I was traveling back from South Korea, where we had the headquarters, and I hired a taxi, and the taxi driver was really drowsy and sleepy. And there was one point when this guy almost dozed off, and I could see that he's about to hit a divider. And then I make him stop the car, and I made him sit in the back seat, and I drove the vehicle by myself to reach my home. So during this time, I was thinking, I've been working for multiple foreign companies, helping the people all around the world. When I have the people from my country trying to earn like 150 rupees and taking the risk of his life, like if that accident happens that night, then I would have been going scratchless, because I was sitting in the rear seat wearing the seatbelt down, and this guy was not wearing the seatbelt. He took the seatbelt out and buckled him through the rear, and then he was driving it. So he's taking a risk. So I was thinking, like, why don't I think about? I did my PhD in robotics and mobile robots mostly. And I was thinking, like, why don't I think about driverless cars for an Indian kind of a scenario? I didn't think much about the economics, the driver salary, and all those things. It was something which is like really fancy to think about and tough to really do it. This was back in 2010. So then I told this the very next day I told this to my team members in my team, and they were also super excited about this whole concept of building a car and all those things. And during that time, there is news about Tata Nano coming out. And we were analyzing the different cars, like what all cars can we use for such a project and all those things. And Tata Nano turned up to be the best candidate because of its rear engine design. I thought all these actuators to control the steering and pedals and all those things can be fitted inside the front portion, because it's a rear engine vehicle. The front portion is free. And then we started, the vehicle was not out, but we got the data set or the size of the vehicle from the website. And then we started working on creating a simulation based out of Tata Nano, and to see whether the software development, where we can do a distributive kind of a software development, where all this visualization, all these simulations sends data to my driving algorithm, where it controls the system, and the driving algorithm feels that the whole data is coming from an actual vehicle. We did a host of simulation. We did different types of simulation, city, clutter, traffic, without road markings and all. You can see the simulation doesn't have any road marking. So we did a number of different types of simulation to see whether the concept would work. And once when we got the concept working, we started working on the actual prototype. I bought brand new few Tata Nanos and then opened it up, reverse engineered, took off all these, and we attached actuators and systems to make it work or make the vehicle work and all. This is a video from 2011 when they released the first generation Tata Nano, which didn't have even a power steering. It didn't have an automatic transmission, it didn't have anything. So we imported all these sensors from Germany, and then thereby we were working on like how we can integrate these sensors and all those things. And then we started working on a concept called Uberization or vehicle on demand, where we created the whole software interface to see whether the whole concept is working. Where we are working on a real. This is in Kochi, near the Info Park Expressway, where we are testing this vehicle, where we are doing a host of different types of research to see whether the vehicle can drive by itself. We are creating prototypes, we are creating algorithms, and every weekend this was kind of our job. And we have been working on different types of navigation with rudimentary sensors and all these sensors which you see on top, where I couldn't get an approval from the India government because it's named as SICK. Then I got a special approval to import these sensors. And we created different sets of software stacks which could make this vehicle work. or make this vehicle drive by itself. So we have been doing this research day in, day out, almost all the weekends when we have free time. So I had a very passionate team along with me who were working to see how this thing can be materialized and how we can use it. And this is actually one of the most busiest road today. Back in 2013, it was not too busy because the info park was actually coming up. So now we have a metro station and all these things coming up. We did so many safety-related research on the vehicle, jumping in front of the vehicle and seeing whether the vehicle would stop or, all those kinds of research. This was like around 10, 11 years ago when we were doing. So we were trying different four-factor vehicles, what all this can be installed and how quickly this can be installed, and all sorts of research we have been doing. And then, we are continuously doing it, but we are trying to see what is the business application of it, because we heard we could hear that there are so many startups around the world, specifically in Silicon Valley, doing this type of research. And in 2020, we had even better, bigger prototypes. We started building on bigger vehicles, on bigger sedans, where we are, how to see this whole concept would evolve from a small car to a larger car. We have been doing this research for day in, day out for quite a long time. This is in the early 2020, and then we had this, this COVID shutdown, where the whole, all of a sudden there was this whole lockdown came in, and the whole research came in, and whole research had to be halted. But then after looking at the news, we found that there is an opportunity which is emerging. So during the COVID time, there were most of these companies like seaports, airports, or mining industries is actually really hit because they don't have an autonomy, or they don't have solutions for autonomous. And that's how RoshAi is formed. So we found that there is a business opportunity. We found that there is a specific requirement in business which would require driverless cars, and there is not too many companies. So almost all these companies which you see, like Waymo, Motional, Kodiak, and all are into ride-hailing services. And there are the number of companies which is into mining autonomy or retrofit autonomy for mining or retrofit autonomy for seaports is very, very minimal. There are a few startups, and what we have identified is the capability to build a retrofit system which goes on to any type of vehicle. Let it be a truck, let it be a bus, let it be any of those kinds of vehicles, and that formed the fundamental of RoshAi. And 2021, I was the global head of robotics and cognitive systems at TCS, and then I quit the job to start RoshAi. And today, I am the supplier for software stack on driverless algorithms for taxi fleet companies, and that too in US, in Middle East, and there are the number of ports in India, and also manufacturing companies which would actually require these kinds of advanced autonomy solutions. And we have created a host or I would say a prototypes based on different types of vehicles, SUVs, MUVs, sedans, light commercial vehicles, and we are also working on large trucks, which is used in seaports, which could automate. So we are specifically, what we are specifically doing is democratizing the concept of driverless cars and demystifying it, and make customers or enable customers to actually use it for their benefit to reduce the operational costs. And moreover, driverless cars are not a fancy thing anymore. We have been hearing about news, and almost all these people who want to invest in this money want to see what is the return of investment I'm getting from this. That's how we started the whole point of how to develop driverless cars so that is useful. For instance, we all see these robotic vacuum cleaner advertisement in almost all the magazines. Even I could see this in Vanida, right? Robotic vacuum cleaners are the thing right now. Like, you can buy it. I think there are so many stores in there where you can buy it. But it's a fancy for 2 weeks, right? It looks like, okay, it can go anywhere and it can clean it. But after 2 weeks, you will feel that I can clean better than this. I wouldn't take this much time to clean it. The only thing, it is showing is the fancy. So the same thing shouldn't go for autonomous vehicles. And that is the reason why we have built a number of software applications which could connect it to, to the customers, and the customers would be able to see the amount of productivity the whole thing is bringing in. So if you see a seaport or an airport or any of these automotive companies, anybody who spends money on it is not spending for the fancy of it. They're spending it for the return of investment, how well they can do the return of investment. And RoshAi stands for, we are into licensing the autonomy, the AI applications and the AI systems which you have created. We are into licensing the whole autonomy and the autonomous algorithms. And we are a vehicle and a sensor agnostic kind of a stack which we have. So if a customer, like we work with different types of customers, cost sensitive customers like automotive companies. I'm supplying for one of the largest automotive car companies in India, where the cost is a factor. So, for them, like for creating these driverless cars wouldn't come overnight. It will come as a series of features which is added. And some of you would have seen the new Mahindra BE6C advertisement. That's Mahindra released a new vehicle, an electric vehicle, which has auto parking. You put a button and the vehicle will go and park by itself. And these are some of the small features which would come in, and it will then graduate to a fully functional driverless car. And that too, doing it in India is one of the most toughest jobs, because we do have a very, I would say that a chaotic or a defensive way of driving. And when we are driving, we are always on a state of mind where somebody is going to jump onto the road, and we are always alert. It's completely different when you see it when you drive on a foreign country. And on our as a portfolio, what we are developing is specifically an operating system. An operating system which customers can actually use it. And the operating system doesn't make any sense. Where do you fit an operating system on a vehicle? So then you need to have something known as a drive-by-wire system, which we have actually created, which would, the retrofit system, which would go into any vehicle. If you give a 1950s vehicle, then it will work. If you give a 2024 electric advanced vehicle, our systems would work. So ours is a retrofit kind of an autonomy system, which you could directly fit onto any type of vehicle. And then we are coming up with a concept called data for self-driving network as a service. So it's kind of a SaaS kind of an enablement, which helps customers to use the concept called pay as you go. They don't have to spend too much of upfront cost for them to do the deployment, and that is one of our business models. And then we have something known as a data first approach. So for automotive companies, as I mentioned earlier, currently what they need is they are dealing with a cost sensitive market. Like everybody is asking for, like, I'm spending like 2 lakh rupees more. What am I going to get? So for them, we do have a release, a flavor of our autonomy software, which uses cameras and which uses much more cheaper sensors. It's mostly used for ADAS and ADAS related application, advanced driver assist system. For customers like seaports, we have much more advanced, expensive kind of a solution, where the amount of error rate which we are doing is plus or minus 5 centimeters, which means that if a car which we are building, or a truck which we are building, goes from point A to B and then coming back to point C, or no matter if go to point C, A, B, C, and then coming back to A, the error rate which the vehicle should be stopping should not be more than plus or minus 5 centimeters. So this is the kind of applications what we are actually developing, and ours is a segment agnostic kind of a system, where we can apply this on different types of verticals, and we are creating different verticals which are specifically onto this. And how we are doing this, and why am I doing this in India? Because the major thing is the ability is to create a system where the cameras and sensors are able to capture the information and learn from the way people are driving. And so for that, we do have an unconventional way of programming the system. This is our prototype vehicle, which has all the sensors and systems and ability to capture each and every minute data. And we do have we work out of Infoburg, Kochi. We do have a 6 kilometer long test track. And with this, like we make these auto rickshaws and all these vehicles which you find in India drive in specific speeds and specific patterns. Thereby, we are collecting the data, and thereby we are teaching the vehicle how these unconventional vehicles like 3-wheelers or 2-wheelers or the pedestrians, all those things, how they are being tested. And with this, we are actually testing. We take our vehicles to different test tracks in India, where we hire the test tracks for a few days, and then we do the testing over there for high-speed testing and all. So the point is, what we actually do is challenge or test it with multiple very complex test environments, but actually we test it on a much more, on the customer deployment, we test it on a much more simpler kind of an application. One of those things is like, what we are building is a Fleet Plus Pro software, which is actually enables our customers to specifically see what is the productivity each and every truck is bringing in. So it's not about making the vehicle drive by itself. It's about giving the customer the feel that how much productivity this thing is bringing in, how well they can connect their systems to our systems in a much more seamless way. So this is what we are building. We are building a host of features onto these Fleet Plus Pro software, which is our advanced autonomy interfacing software. So if a seaport is coming, they have something known as a terminal operating system. So this thing, our Fleet Plus Pro will connect with their terminal operating system or their management tool or their SAP front-end interface, where we are connecting the whole ability for the customer to actually utilize the features and the advanced features of all these things which you are building. And it has a host of features, and even predictive maintenance or live map update and all those things are there. And also it has a feature called a remote pilot, where the customer would be able to, so currently what we are working on a concept is like there is one driver for 5 autonomous vehicles. We are scaling up to an ambitious goal of one driver per 50 vehicles. So how do we do it? The vehicles will be able to drive by itself. It will be able to take decisions. It will be able to manage most of the traffic. But there are conditions where something which we wouldn't have trained the vehicle with. So on all those kinds of difficult traffic situations, what the vehicle would do is like it will shift the whole control to a remote driver who would be able to help the vehicle come out of that particular traffic kind of a condition. So that's how we are building the whole ecosystem. It's not about building the vehicle to go from point A to B. It's all about the whole ecosystem software, which would help our customers utilize this power of technology for their day-to-day applications, or for reduce their operational costs or increasing their productivity. We also have all these prototype vehicles which we have built, which we take on to customer spaces. This is one of those prototypes which we send to customer spaces, where they'll be able to feel a live feel of how this vehicle would work and how this is actually running and all those things. And we have created the spin-outs. The spin-outs of this thing is like what we have created is the driver monitoring system, which we are supplying for companies like automotive companies and truck manufacturing units, where it looks at the driver and sees his attention to the on the road. So this helps customers. This is actually a spin out from our actual autonomy research, which can be utilized for customers. So the point is, I'm creating perception software. I'm creating an ability for AI to look at objects or look at the environment and create insights out of it. I'm pulling out that insights part and creating and selling the perception software separately. So that also becomes one of my revenue channels. So when you build a startup, you should always have this focus on revenue. Where am I going to sell this, and how much productivity every customer is going to get because of such an application which is being built? How can you channelize it? How can you make it fragments and then sell each and every part of it so that you create revenue the whole thing? That helps our investors, or that helps the future customers to see how well we can do it. And moreover, all these things will become my data corpus for teaching my AI to become much more smarter. And we as a startup, we do have 14 plus years of experience in developing scenarios specifically for India, and we are expanding to different parts around the world, where we are doing a country adaptation, where on one side I'm teaching my algorithms and my software with these advanced different solutions or different problem statements which you see on Indian roads, which is basically the chaotic driving or the defensive driving, and creating algorithm based out of it. And when I deploy it in Middle East, what I need to do is a country adaptation, because they have a left-hand kind of a driving kind of a scenario. That's what we are doing currently with my team in different parts around the world. We started our operations in Hyderabad, and then we moved to Kochi because of the support given by Infobarks Limited and also Kerala Police. And to commemorate 1 year of operations in Infobark Kochi, we did a private event with the help of an NGO called Center for Empowerment and Enrichment, where we were able to show the children with special needs the vehicles which are there. So initially what we did is we gave the parents and the children about a brief about how this technology works, and these children would require someone's help all the time. And then we gave a demo of the vehicle and how the vehicle would drive by itself, and giving these children an assurance that all these forthcoming technologies are going to change their way of living and the quality of life. And thereby, it helped my.
Wonderful.
I did it on purpose, in the sense like I want to improve the morale of my team, and also to seeing the happiness on the faces of these children. It was priceless for us. And we did this event like we do events like this for, these are not public events, these are like very private events. The support which we get from Kerala Police, Kerala Fire Force, and they'll be staying on standby specifically to help us. So these are some of these ecosystem advantages or ecosystem support which we get from different stakeholders in the government, and also in Kerala specifically, to run these kinds of programs. And the happiness on their faces was like too good for us to do the development. And in last year, we during December we participated in a Government of India program called ADAS Show. ADAS Show. It's a Government of India funded program. So we took our prototypes to Delhi, and this is a video from it.
RoshAi. Based in Kochi. Headquarters is in Kochi actually.
So we
it's running on its own. No, it's its own. I'm not doing anything. You're not doing anything. You see my legs now. So here the ultimate part is actually, so even just to provide you, okay, this is a start point is A, there's an end point will be B. Something like that we will provide. So we'll be parking the vehicle in the Hyundai Motors vehicle is there, no? Park the vehicle over there. So while driving right now, you just try to understand the environment, that and everything will be taken care. So here, if I apply the brake, it will be just override. Override. So override is still there? Yeah, still there actually. So
we did a host of media events that day with different media celebrities. My journey on driverless cars has been there in media for the 10 plus years on different news and media around the world. And now RoshAi, the startups activities is getting into limelight. So we work out of InfoPark, and I do have my prototypes and test tracks and all those things in InfoPark. We also take it to different places. So I would like to really give a demo to all of you. For the interest of time and convenience, I have compiled a video here. We have an Instagram channel where we upload the whole videos and the development process and all those things. This is basically to give people on like these kinds of things can be done in India or in Kerala. So if you scan this QR code, you can directly get in touch with our Instagram channel. Thank you very much. I'm open for questions.
Hello. Can you hear me?
Yeah.
First of all, congratulations.
Thank you.
And it is really wonderful to see a Tesla in Kerala. So it's a great achievement.
Thank you.
Now my question is, see, I seen a demo of this in Kochi some years back in the cybersecurity conference. I'm not sure whether you are.
That is me.
Oh, okay. So that time, probably it has been addressed now. But the question which I had was about the security, how hack-free or how much of hacking, somebody can steal the car, or is there a security threat for the passengers? And probably if you can just
Yeah.
Provide your thoughts.
What we do have a specific cybersecurity practice which we do it. Uh, there are multiple levels to it. One of those things which we do inside is like we hire hackers and do hackathons to. This is a private event, not like public. Also, this is like for our internal development. External development, we are signing an agreement with a company called Nexiad, which is into cybersecurity from France. So they will be doing the audit on us, and they will also be working on our technology to make it much more secure. So this is cybersecurity is one of the topmost priority which we do, because it's an autonomous vehicle. You can easily weaponize it. It's like the regulations or the seriousness has not come from anywhere, but I take it like super serious, and we do have multiple levels of cybersecurity audits which we do all the time. So yeah, so that has been taken care. Yeah, so that's and moreover, I need to have all these certifications to be shown to my customers for them to take this. So that's why I'm reiterating the statement once again. Driverless cars are not a fancy anymore. They have become a utility. They're going to become a commodity where you have to rely on. Like we are going on to that journey. Probably in the next 5-10 years, you will see much more in a regular way. It wouldn't surprise you anymore. So that aspect of it, the cyber security aspect of it, is super important for me. We have different levels of this one, from hackathons to external companies who would certify the products which you are releasing.
Okay. Is it all? Okay. Yeah, the deep learning has more or less, solved the computer vision problems related to ADAS. So, would like to know from the view, is there anything challenging things which are still remaining and troubling?
Absolutely. The way we drive is a challenging thing. So there are multiple levels to answer your question. One of those things is like what you rightly pointed out, which I wouldn't agree 100% on. Deep learning has solved most of the computer vision problems. It's not. Like still, the deep learning, we have to train with scenarios, right? Identify an object is one thing. Seeing an apple and saying that it's an apple is one thing. That's an older kind of a thing. What we are trying to do currently is scene recognition. How are you using deep learning to understand a scene? When you see an auto rickshaw driving, you should know that it's an auto rickshaw. It has 3 wheels. The way at which it take a turn is totally different from a car would take a turn. So these kinds of knowledge imparting is one of the most toughest job, and we also have to do this on a vehicle. And we have to ensure that the whole thing works when you don't have a 5G or a 6G connectivity to your whatever cloud service provider you have. So these are some of the daily challenges which we face, and we are solving it in an unconventional way. There are multiple ways to solve it. One of the ways which the Silicon Valley or the Western world approach is using simulations. They do have extensive simulations which cost a lot of money in procuring the license, which we are doing it on an actual stage, right? The Western world are trying to solve this highway kind of problems, because most of their traffic is structured. But I'm trying to solve it on the chaotic space, where how does it work on a silk board or maybe on a Madiwala, or maybe in front of a secretariat when there is a fight is happening. How do you manage such a thing? So I'm trying to recreate these kinds of scenarios and teach the vehicle or teach the algorithm on, okay, this is that. This means that, or the identification. So that is the level of deep learning I'm trying to solve. It's not about the conventional identifying an object. Those days are gone. But that is what we're trying to solve. Thank you.
Yeah, it was very illuminating. Yeah.
Thank you.
First of all, thank you for the wonderful presentation, sir. So when can we expect driverless vehicles in Indian roads? What are the any challenges or restrictions from the government side, or any regulations?
It's a political kind of a question, but what we see is like, as I said earlier, there is this new vehicle which is released by Mahindra called BE60 and BE90. It's an electric vehicle. All these vehicles have auto parking as a feature on the top end models. So it doesn't come overnight saying that, okay, tomorrow morning you'll get all driverless cars. It doesn't come like it. It comes gradually. The stepping stone towards it is the ADAS features which you get. Like when you try to take a left turn, the vehicle will give you a warning saying that there is somebody who's coming from the blind spot, right? These kinds of things, and then it gradually graduates to driver fatigue detection, where if the driver is too drowsy or not able to drive the vehicle or not able to put focus on the road, the vehicle will take control and probably stop it at a much more safer place. These are the small steps which would come to to the overall kind of a scenario. This is how the features would add in, and then the consumers would ask for more and more features, and that's how I see it, or that's how the whole industry sees it. But today there is a requirement for seaports, right? Not the consumer application, the professional application. That is how we see it. For me, I work with almost all the automotive companies in India. For me, it is B2B2C. I'm selling a software to these companies, and they are selling it to their customers, which are basically consumers. So it's a B2B2C scenario, so where I'll get multiple checkpoints, like the gentleman said. I do have a checkpoint for cybersecurity as well. So if a car makes an accident, it's not just my problem, it's not just a software problem, it's a collaborative kind of an issue where we are trying to solve it. So this is all good. Yeah.
By the way, very impressive work.
Thank you
I
very
have
much.
one question.
Yeah.
Millimeter wave radar, are you using it? Or?
Yes, we are using it.
So it's a millimeter wave radar,
I-
LiDAR, camera.
Cameras. So we do have multiple implementations. I do have a number of prototypes which are not seen outside, or the videos that we are developing. So we do have an implementation with the array of radars and camera, which is much more cheaper implementation. We do that research for automotive companies. We do have multi-radar approach, which is used for seaports, more of professional application. So all these things are coming. I am using, LiDARs, radars and cameras, but my software is reconfigurable. It doesn't mean that it only requires LiDAR to work, it will always require LiDAR to work. It's not like that. We are customizing it for a customer kind of a requirement.
I have one more question. On this scene recognition thing you have talked about,
Yes.
it's an endless problem, right?
Yes.
So where do you put a...
So that is the point. That is why I have put this remote pilot, a remote driver, where almost all the scenes cannot be taught. Almost all the scenes cannot be learned. So if there is a new challenge which is coming in, on one side it will capture the data, on the other side it will send it to the remote driver, so that the driver can take the vehicle out from a congestion or anything, and gradually it will improve my AI software.
But if you look at it, humans don't try to understand the scene, right? You just look at it as an obstacleized topic. Why can't you go that way?
I cannot, because we cannot go with an ambiguity kind of a thing for a machine learning algorithm. We have to have some
humans
sort of a
do,
prediction
right?
score.
Like if I don't care whether it's auto, I just look at it and just talk. If
No,
I-
no, we do have a much more deeper understanding on which we are.
Why, my question is why it's needed?
It is needed because we need to see, like, when a vehicle is driving, when you are on an autonomous vehicle, when you are developing the algorithm for it, you have to have an idea about all these obstacles which are there, and we have to have an idea about what is the probable trajectory positions. It can stop, but it will stop. How will it negotiate an obstacle? If something comes in, it will stop. That's true. But it has to go away, or it has to do a negotiation. It is not like a robotic indoor kind of a thing. It has to understand, then only you will get a certification, then only you will get a much more deeper understanding of how these things are working.
At the base level, you can use that.
Yes.
Like
So,
data.
yeah, so that stack helps me, that is the stack which I'm trying to build, where I know about these obstacles, where I'm trying to add in more obstacles, and we also see these dogs and cows and cattle and all those things on the road. You find only in India, nowhere else. So how do you, characterize it? I'll tell you an example. I say this example lots of times. So what we do is, like, we do collect data, right? So there was one time when we are in Hosur, near Hosur, we are actually driving on an interior road, and there was this tea stall on one side, and there is this, the guy who is actually making banana chips or something. They have this ability to peel out the banana without, taking the whole stick, right? And he was throwing the stick from one side of the road to the other. So my radars and lidars picked it up. Camera cannot pick it up because it was getting dark. We could see that something which is bigger than a dog, which is flying from one side of the road to the other. right? But it's not a dog. So how do you identify with the inferencing module that, how do you identify that this is not a dog and this is something which you have to characterize? It may have a size of a ostrich or something where he was throwing it from one side of the road to the other. So these kinds of challenges would always come. So the major challenge when you sell it to, when you sell the software to an international client is that our ability to do it. We are not creating a delivery, last mile delivery robot which could stop at an obstacle and stop right there until the obstacle moves out. We are developing a vehicle which should have at least the level of intelligence a human is having and more alertness. So that is what we are trying to build, and all those things would require the characterization of the obstacle, the gait of the obstacle or the motion pattern of the obstacle, the predictability of the trajectory of the obstacle. So these are some of the things which you have to work internally so that I'll be able to navigate in a much better way. Thank you.
Hello.
That's all. I think, yeah. Any other?
Yeah, good morning. Just one small doubt. Since you said about training different scenarios, have you ever tried out synthetic data generation kind of?
What do you mean by synthetic? On a simulation or actual? We always do synthetic data simulation. I hire like 25 to 50 auto rickshaws a day.
Oh, okay.
Tell them to drive the way they
I was
want.
talking about something different, because I'm basically from an AI background for manufacturing, defect checking for manufacturing.
Okay.
So where we create artificial data set for each scenarios like a scratch and
Correct.
something similar to your case. It's uncertain.
We do that,
Yeah.
but currently our schedule is on creating all these complex traffic scenarios on a road kind of a condition.
Sure.
Not on a simulation. And then we capture the data. We use Gen AI to create even more data out of it. I think that's what you asked, right?
Yeah, I have
We use
seen.
Gen AI to create more scenes out of it.
Actually, we could use softwares like Blender. I don't know whether you've heard
Yeah,
of
we are
it.
using it.
Yeah, that you can use probably. That's just.
Yeah.
I've seen some presentation where they are using this for
I know.
autonomous cars.
Yeah. So we do it to an extent. What we do is like we create simulated, artificially created simulated data on the actual
Yes.
on actual scenarios. Simulation doesn't mean that the computer simulation. So on an actual scenario, and then we use Gen AI to create even more scenarios so that
Sure.
I can put it on
Generate.
training. Yeah, that's how we are.
Thank you.
What about the empathy? Like, for example, suddenly a car is hit someone, how it will handle?
I was wondering why I didn't get the questions like this. So I get questions like, if my car sees a pregnant woman and a man, whom will it hit? How many years have you been driving?
I don't know driving.
You don't know driving. Probably because of that, I've been driving for the last 30 plus years. Even before I got the license, I started driving. I haven't come out with such a scenario. It's a philosophical kind of a question. I don't have an answer for it right now. It's something which we need to see. There's something which is haunting me in one sense. What if it creates an accident? Who is going to get penalized? So right now, when I give the representation to the police station and all, say that I'm taking responsibility for whatever mishaps which may or may not come, right? It is something which is evolving. It is something which, how do you handle if an industrial robot kills a person? It's something which you cannot anticipate, but it's something which you cannot ignore also, right? So it's something which is evolving. I don't have an answer for it at this point of time. It's still philosophical. We'll figure it out maybe probably when the AI becomes much more smarter with so much of examples. It probably will be able to figure it out. Right now, I'm out of an answer.
Did you train with similar situations, like similar scenario? Like? For example, suddenly an accident happened in front of the vehicle. How will you handle? You trained some?
No, we haven't simulated such an accident. We have other more basic things to simulate than going to the extreme things. Yeah, we'll be taking those things in. Yes. Okay.
Congrats.
Thank you. Okay, guys, thank you very much for the time. I think no more questions. Yeah. Thanks a lot. Thank you.